In this video, we will talk about how to solve a system of equations by graphing. So let's say we have the following two equations. 4x plus y is equal to 2, and x minus y is equal to 3. We want to figure out for what values of x and y make both of these equations true. So the way that we can do this is we can first convert both of these equations to the format y equals mx plus b. We can then graph these two equations and we can find where they intersect, because the coordinates where they intersect represent the solutions for x and y that make both of these equations true. So let's go ahead and do that. So to convert this first equation to y equals mx plus b, we just need to subtract a 4x from each side. So that will give us y is equal to negative 4x plus 2. So notice it's now in a format of y equals mx plus b, which makes it easy to graph. So let's do the same thing with the second equation. So if we subtract an x from both sides, we'll get negative y is equal to negative x plus 3. And the last step is we need to get this negative y to be a positive y. So we can multiply every single term by a negative. So that will get us y is equal to, instead of negative x, now we have a positive x. And instead of positive 3, we have minus 3. So here are our two equations that we will graph. Y is negative 4x plus 2, and y equals x minus 3. So when we're graphing these equations, we can start by finding what is the y-intercept of each graph. Or in other words, when the x value is equal to 0, what is y? So if we plug in a 0 right here for x, we get 0 plus 2 for y. So that tells us when x is 0, y has a value of 2. So right here, I'll put a little dot. And now we need to graph the slope. So the slope right here is negative 4x. So remember slope, I'll write m for slope, is equal to rise over run. So that tells us to graph this slope, we need to go down 4 and to the right 1. So let's do that. So we'll start from this y-intercept. So we'll go 1, 2, 3, 4 down over 1. So that's the point right here. So if we connect these 2 points, we can roughly get a line that represents this first equation. And now we need to do the same thing with this next equation. So y equals x minus 3. So again, let's find the y-intercept. So when x is equal to 0, we can see that the right-hand side is 0 minus 3, which is negative 3. So that'll be right about here. So I'll put a little dot right there. And then we need to graph the slope. So right here in front of this x, we can imagine there's a 1. So the slope is just 1, or in other words, the rise over run is we need to go up 1 and to the right 1. So if we go up 1 to the right 1, we'll get this point right here. And we can draw a line that kind of connects these 2 points. So here's our second line. So we'll notice that the point of intersection is right here. So the point 1 comma negative 2. So let's write that. So that is our answer. If we want to double check that it's correct, here's how we can do that. We should be able to plug in a 1 for x and a negative 2 for y in both of these original equations, and we should get a true statement. So let's check the first equation. We had 4 times x. So if we plug in a 1 for x plus y, we said y is going to be negative 2. We should get an output of 2. So see that? We just plugged in those values for x and y. So let's see what we get. 4 times 1 is 4 plus negative 2, so minus 2, is equal to 2. So we get 2 is equal to 2. So that checks out. That's a true statement. Now let's check the second equation. We had x minus y is equal to 3. So again, let's plug in a 1 for x and a negative 2 for y and see if we get a true statement. So 1 minus a negative 2, that would be 1 plus 2, is equal to 3. So 1 plus 2 is 3, which is indeed equal to 3. So that checks out too. So we know that 1 negative 2 must be the correct answer because it satisfied both of the original equations. So that's how you can solve a system of equations by graphing. Simply graph the two lines and find the point where they intersect.